All right, so we're starting 2122. And next week on Tuesday, continue with whatever loose ends 22. But 23 square roots, simplifying square roots, cube roots, fourth root, fifth roots, imaginary numbers, complex numbers. 23 is a lot next Tuesday. We need that information, so we do 2425. Okay. 2425, 24 starts on Thursday. You're going to get on Tuesday quiz prep for 2122. And the quiz will be Thursday. On Thursday, you get the quiz prep for 2.3. Next week, the week after that, on the 22nd, going to finish up chapter 2. Get the review sheet. Take the quiz on the 22nd for 2.3 only. Review on the 24th. And the test is right now, scheduled for the 29th. Do not run off and set up a testing, reserve it yet if you are going to take it in another place. Because sometimes that date moves. I would at least wait to see where we're at by next Thursday. Okay. Last day to drop is tomorrow. Last day to drop an 18-week course. So any 18-week course is tomorrow. Here's your grade in this class. It's based on your quiz scores. That's all we have. So you know what your quiz scores are. Okay. I dropped 2 lowest quiz scores at the end of the semester. We have 2 more quizzes there, and at least probably 2 more quizzes after that. Okay, at least 2 more quizzes after that. So 4 more quizzes, at the least 4 more quizzes. The final replaces your lowest test score, provided the final is higher than your lowest test score. I will not answer this question because I can't answer this question. And I don't want to answer it anyway. Can I still pass the class? Because whether or not you can pass the class is not up to me. I'm not the one who's doing the work. You're the one who's supposed to do the work. You're in charge of grading your own homework. That means you're in charge of doing your homework and grading it with honesty and integrity and blah, 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 blah. So that's 18% of your overall grade. That should be solid 18% right there, 100% out of that. But if you don't have 100% out of that, then that's on you. Quizzes can go up. Some quizzes have bonus points on it, which means if you missed a quiz or you have a low quiz score and you have 3 bad quizzes and we only drop 2, well, bonus points on a quiz that you do really well on can help bring up your overall quiz average. But again, that's on you. Finally, replacing your lowest test score. If you missed a test, nobody in here missed it. But whatever you got on the final, if you had a 0 on the test and you get an 85 on the final, the 0 becomes an 85. But it only replaces 1 lowest test score. Okay. I'm offering bonus questions for the chapter 1 test. Okay. You have, from yesterday, 7:30 office hour, until next Wednesday's 7:30 office hour. And it's not just 7:30 office hours. Any office hour between yesterday, which doesn't matter anymore, but any office hour from now until next Wednesday. There's 8 bonus questions at 4 points apiece. So there's a possibility of 32 more points you can put onto your chapter 1 test. How many of you saw and actually opened the announcement that I sent in Canvas on Tuesday night? That many, huh? I've seen a little bit like it. I sent Somebody Tuesday before they left just said, what's on the bonus question? What are the bonus questions like? I said, well, we talked about it during when we reviewed throughout this whole lecture series on chapter 1, here, there, and everywhere. And I pointed everything out. Not going to ask one of these on the test, but it's not going to be a mandatory question. But, well, Tuesday night I went down and made a whole list of what and where you should find those things that might be on the bonus questions. So you know exactly now what they would look like. Do not show up for the, if you come to 7:30 to do the bonus questions, it's 7:30 to 8:20. Don't show up at 8:15 and think you have 50 minutes. It ends at 8:20. Tuesdays and Thursday office hour, you guys are lucky. Monday, Wednesday, I don't have this. But Tuesday, Thursday office hours from 12 to 12:50, right after class. Not 11:50, but 12. Give me a chance to, clear my head a little bit. Don't go away and then come back at 12:30 and think you still have another 50 minutes. It ends at 12:50. Okay. So, see the Canvas announcement that was sent out on Tuesday for basically bonus clues is what it was in the subject line. I don't want to see anybody drop, but it's a decision that you have to make. I know why people ask the question, can I still pass the class? It's because you want permission to quit. Well, you said I wasn't going to pass the class, so woohoo, I'm done. I'll take the more. Or you hear the yeah, but you only hear yeah. You don't hear if you. Not if you, but if you. Okay. If you do this, this, and this, and this, are you on tutoring? And you have a study group? Are you coming into office hours? If you do these things, and then I talk about how lowest quiz scores get dropped and final replace lowest test score. So I would say yes, if, but they don't hear the if part. All they hear is the yes. And so if it doesn't happen, they come back at me and say, you said I was going to pass class. You said yes. So that's why I don't answer the question. I learned a long time ago. If you need to know because you just need to know, you're one of them, and you have to know what your grade is right now based on your quiz scores. Because that's all you have is quiz scores. I don't even have a homework grade in there yet. No test score. Test scores are 64% of your overall grade. Quizzes are 18, homework is 18. So between now and Tuesday, when you get your test back, your quiz will change. Well, depending upon how you do, should change a little, dramatically. If you're doing really well and you do really well, it's not going to change that much. If you have great quiz scores and then you don't do so well on the test, it's going to change quite a bit. It just depends on how the averages work out. But understand, and what I was getting at is if you need, that visceral, I need to know. If you email me, not through Canvas, do not hit reply all through Canvas. I will not respond to Canvas. Never going to send grades through Canvas. Email me from your own email address. Make sure you put your name in there, class and all that stuff. I can send you a PDF of your overall grade of where you are right now, but understand it's going to change by next week. Number two, the more of those that I have to fill out and send out, the longer it's going to take for me to get back to grading all the tests, when all of those scores are going to change. But if you need to know, email. Any questions? Chapter 2, we are solving equations. 2.1 and 2.2 are linear equations. . Linear means x to the first. So the power of the variable is 1. And then when we get to 2,4, we're going to deal with x squared, quadratics. And then 2,5 actually mixes it all up. We're going to be able to do x to the second or x to the fourth, possibly even x to the sixth, or maybe even work out some way x to the thirds. But we're going to use the techniques that we learned here to build upon. Let me try to get that high enough so it doesn't show my fat belly. There we go. Step by step. You gotta do it step by step from the very beginning. Quit thinking that you know exactly what you're doing if it's not working. If what you're doing doesn't work, change. Change what you're doing. Forget everything else. Stop doing it your old way. And from right now on, start doing it as you're seeing. Practice it the same way every single time. If you commit yourself to that discipline, who knows? Talking yourself through it, doing your homework that day. I don't collect homework the next day because I know you have other things in your life that you have to attend to. I give you that freedom and I want it on the day of the test. That is not conducive to everybody because it doesn't always generate the most attentive method of doing homework. I don't know how many of you wait until the night before. I'm pretty sure I can tell how many of you are just copying shit down. Calling it good, which means I'll see great homework, 100% on the homework, and the test is abysmal. Last semester, I saw 100% on the homework and then a 1 out of 150, 1 point out of 150 on the test. How did you get 100%? Get all these right. I mean, the work was there on the homework. The work was there. So, hey, they seemed to get it. But then the questions were just basically left blank. I think they started one, so I gave them a point for something. I don't know where, but it was literally 1 out of like 150. So it's like when I noticed they were doing a warm up with the computer and the AI. Oh, that's how you do the homework. Doesn't do you any good if you don't actually practice. What was the review sheet like the test? That's the. I would argue that that's the teacher. Yeah. I wouldn't disagree. I do try to make the review sheet a little bit more, angrier than the text. Because I want you to come in and have the confidence, I can handle this, I can handle that. But if you don't actually try, I guess I better take a roll now. I think everybody might be happy. Always something. Anniversary, birthday. Kaylee, Christian, David, Mandy, Riley, Brianna, Becca, Brianna, Heather, Kimberly, Bizarre, Gabriel, Myra, Angel, Wonka, Jose, Vanessa, Dakota, Jenna, Manny, Alita, Christopher, Oswaldo, here. Jesus, here. Diana, Isabella, here. Sophia, Lisa, here. Talia, here. Matthew, here. Nancy, Joanna, Kelly, here. Aiden, here. Yenica, Rob, here. Edgar, here. Rodolfo, here. Capri, here. Melina, Ida, Blake, here. Melanie. And assignment sheets. If you came in late and still need an assignment sheet, they're up here. Make sure you grab one. If you want to get up now, go ahead and do it. All right. Okay. Solving linear equations. A linear equation is an equation that looks like this. Something times x plus or minus some other number equals a number. Like number 1. Okay. 12x minus 9 equals 18. Now, you could have stuff on both sides. You have a whole bunch of stuff going on. But the bottom line is it's x to the first. That's a linear. Step number 1 for solving. Simplify both sides completely. You need to simplify both sides completely. The biggest mistake that I see people do is they try to solve the problem in the first step and they don't simplify. They think you think you can get done in one step. No. Before you try to start solving the thing, you want to clean up your, each side, combine your like terms so you have less to work through. Now there's an extra piece for step 1. So leave a little room because I'm going to put something there. We'll come back to it when we run into it. So question number 1, simplify both sides completely. This side is simplified. You can't combine 12x minus 9. Well, 18, that's as simple as that's going to be. That's simplified. Both sides are simplified completely. But I'm also going to show you this one at the same time. So we have something to compare with. Over here on this side, we have some work to do. Simplify both sides completely. So here, inside the parentheses, you can't combine x minus 3. They're not like terms. So you have 4 times the parentheses. We distribute 4 times x. And keep track of your signs. Positive 4 times negative 3 is going to be negative 12. And then you still have 3x equals, this is 1 plus 8x. Here, I've never actually pointed this next part out, but I see it happen way too often. So now I've decided I'm going to go ahead and point it out. Step 1, simplify both sides completely. So don't stop until it's done. Step 2 is when you're going to get your x's on one side, your constant on the other. But I see this happen and I see some confusion. So don't write this down. Then don't do this ever. What I see is a student will think to combine the 3x and the 4x, they do this. That is incorrect. An equation, it's equal because it's balanced. Both sides are equal to each other, like a scale. We're thinking of the word scale. Over here on the right-hand side of the scale, I subtracted 3x and another 3x. I've taken 6x away from the left-hand side of the scale, and nothing from the left. There's no longer balance. Whatever you do to one side, you have to do to the other side to keep it in balance. So that's not how you simplify this side. They confuse this step with step 2. So what you're doing is you're combining like terms. You're looking for the x's on the left-hand side that you want to combine.
you have 4x's plus 3x's, that's 7x, and then a minus 12 equal to, the right side is simplified, 1 plus 8x. But you're just combining your like terms, adding what you can add, subtracting what you can subtract, but that's it. You don't have to do this, but when I combine like terms, I check them off above it, so I know I've taken care of all the x of the first. Everybody's been accounted for. It's kind of like when you go shopping, you have a shopping list. I want to gather up all my x's and put them in the same basket. I have 4 x's, positive 3 x's, put them in the same basket. There's 7 x's in that basket. Now I check them off the list. What else is on the left? I have a negative 12. One other thing I want to point out, please. I demonstrate it this way all the time. Work the problem from left to right and then bring it down from top to bottom. So I distributed the 4 times x minus 3, but I'm going to write the rest of the problem right down below it. I'm not going to just distribute that and then have, try to have this catch up with it over here somewhere. Because that's what I will see. I'll see this kind of happen over here, maybe a little bit over there. Somehow the 3x is forgotten. And they just bring the 1 plus 8x. Sometimes I'll see this, which is really weird. I'll see the plus 3x 1 equals 8x. So all of a sudden the equals is between the 1 and the 8x. And it becomes a problem that wasn't asked. So if you organize and do it the same way every time, you're going to have more success. So from left to right, we distribute. And then right next to it, we have still have 3x, and then we have the equals right underneath, and then the 1 and the 8x. Okay, bring it down. And then next step, we combine these two together, 7x with a negative 12, and then I have my equals. And then on the right side, still 1 plus 8x. Step 2. We want to separate variables and constants. The goal is to solve for s. And what that means is we want to undo what's being done to x. X is like a Christmas present. And when you unwrap that present, you need to save the paper. So you have to be really careful as you unwrap the present. It has to be done in a certain way, in a certain order. Okay? We want to separate variables and constants. I hope you take this to exactly how I write it. Gather all of the variable terms on one side. So what that means is when I say take this to heart, focus on the variables first. The whole thing is about solving for the variable, solving for x or y or z or whatever, t. So let's get the variables by themselves first. Then we'll worry about the constant. Okay? Gather all the variable terms on one side and your constants on the other. Notice. So 12x minus 9 equals 18. There's only one term that has an x in it. Okay, the 12x. So let's leave 12x on the left. There's no point moving it to the right because there's no x's over there anyway. So gather all the variable terms on one side. There's only one, leave it there. So if I'm going to leave the variables on the left side, that means I need to take this constant over to the right side. To undo -9, subtract 9, we add 9 to both sides now. I have to see the work. Or let me put it this way. You have to show me the work for full credit. If I don't see +9 on both sides, how'd you get to the next step? On the left-hand side, all we have left over is that 12x. On the right-hand side, 18 + 9, 27. Separate the variable term from the constant. Okay. Over here, we have a little bit more of a situation of choices here. So when I'm looking at variables on both sides, before you make the decision, and it's a decision, do you want to take them over to the right or do you want to bring them over to the left? Think it through. If we decide to take the variables over to the left side, to undo a positive 8x, you subtract 8x from both sides. 7x minus 8x is what we'll have. Or if you want to take the x's to the right, you would subtract 7x from both sides. 8x minus 7x is what you would have. So if you take them to the left, 7x minus 8x is -1x. If you decide to take it to the right, subtracting 7x, 8x minus 7x is +1x. Think it through before you make the move. But again, focus on the variable, then we'll do the constant. So are we taking x to the right or to the left? To the right. To the right. So if I decide to take these x's over to the right, we're going to subtract 7x from both sides. On the left-hand side, we have -12 equals, we have a 1, 8x minus 7x is positive x plus x. Now, technically, yes, it is 1x, but what is 1 times x? It's just x. So since the decision was to take the variable to the right, that means we now have to bring the constant over to the left. Since that's a +1, subtract 1 from both sides. To undo a +1, we subtract 1. On the left-hand side, -12 minus 1 is -13. On the right side, all we have left is an x. So at the bottom of the box on the test or the quiz or whatever, your x is equal to a -13. When we get to step 5, if you have the time or if you choose to do it, you can check your answer. Before you walk out the door, plug it into the original question, see if it works. Four times x minus 3 plus 3x is equal to 1 plus 8x. And we ended up with -13. So if I let x equal -13, this would be 4 times -13 minus 3 plus 3 times -13. And that's supposed to equal 1 plus 8 times -13. So if that is the answer, the left side should be equal to the right side. On the left, this is 4 times -16 plus 3 times -13 is -39 minus 39. is supposed to equal 1. Positive 8 times negative 13 is negative 104, minus 104. 4 times negative 16 is negative 64 minus 39 equals negative 103. Negative 64 minus 39 is negative 103. So the answer that I got made the last equal right. You can do it on a calculator. If it's a simple enough question, you can do it in your head. But before you walk out the door, you can always plug in your answer and see if it works. That one was done. I didn't go to step 3 because it wasn't necessary. It was X. We want to know what X is. So we ended up with X by itself. Over here, we don't have X by itself. So step 3. But before you write the 3, leave a little room because there is a 2.5. Undo multiplication and or division. So back to problem number 1. It's 12 times X. We want to know what X is, so to undo multiplication, we divide by 12. If I divide the left side by 12, I got to divide the right side by 12. Simplify. So I have to reduce to those terms. Always. No decimals unless the question said, hey, let's plug it into a calculator, let's get some done. So this is X equals 27 is 3 times 9. 12 is 3 times 4. The 3 is reduced, so X is equal to 9 over 4. Write your answer down here, bottom of the box, so we have it. So, original question, check it. Most of the time, people don't like plugging in fractions. I love it. And sure. My $18,000 education, no way, $45,000. I don't know how much. Well, if I plug in the 9 over 4 that I think it's supposed to be, 12 times 9 over 4 minus 9 is supposed to be 18. How many times can 4 go into 12? 3. 4 go 12 3 times. I'm left with 3 times 9. 27 minus 9. 27 minus 9 is 18. So 9 over 4 is the right answer. Four minus. Okay, the analogy I used in the E30 was, if you're moving from one house to another house, you don't move individual items. You pack up rooms into boxes and you move boxes. You clean up your old house before you move into a new house. You simplify both sides of the equation before you start even thinking about solving this and getting X on one side, constants on the other. That's why step one, simplify both sides completely. Everything you can do, do it. You can't do anything in the parentheses. And simplify means take it through the order of operation. Parentheses, 4x minus 2, not like terms. 5x minus 8, not like terms. But we still have to get rid of the parentheses. So here you distribute 3. 3 times 4x is 12x. Careful with the signs. 3 times negative 2 is a minus 6. When you subtract a parentheses, it's going to change the sign of what's inside, because this is negative 1 times that parentheses. So a negative times a positive 5x is now negative 5x. A negative times the negative 8 is now positive 8. And then I want to point out is I'm not going to continue down this left-hand side. I'm not going to just keep on working and ignore the right. Work the problem from left to right, bringing it down, and then keep on going from left to right, all of it. So it stays straight across and nothing is going to get left behind. 8 plus this parenthesis. You can't simplify 2x minus 3. So if we drop the parentheses, we're going to, well, this is just plus. A positive isn't going to change anything. Now, if it was plus 2, distribute 2 times. But it's just plus. So it's like distributing 1 times. 1 times 2x is still positive 2x. 1 times negative 3 is minus 3. But now the parentheses are done. So now we combine like terms. Focus on the variables. 12x minus 5x. So 12x minus 5x, that's 7x. Negative 6 and a positive 8. What does that mean? Positive 2. So on the right, let's right. I don't know why I can't do my left and right. I used to be able to do that. Turn around and mess them up. Okay. On the left-hand side, this simplifies into 7x plus 2. And I'm not crossing these things out, erasing them as I simplify it. As I gather the like terms together, I'm checking them off the list. My x's make 7x. So I'm checking off all the x's. I got that done. Now I'm looking for the constants. I got a negative 6 and an 8. Makes a positive 2. And then I have equal. And it always works better if you keep the same order. Your variable, then the constant. So the variable, the x's, all you have is a positive 2x. And then you have a positive 8 minus 3. What's that? 5. A plus 5. Now, if you put, since you see the 8 first, and you go 8 and a minus 3 is a 5, and then you still have a plus 2x, that is not wrong. You wouldn't lose any points. It's the same thing. But if order helps, organization, order, if it helps, why not take advantage? Look at what we're at. 2 terms on the left, 2 terms on the right. Simplify completely. Simplify completely. Now, focus on the variable. Gather all the variable terms on one side.
So look at the 7x and the 2x. Do we want to bring the x's to the left or to the right? To the left.
So we're gonna bring 2x over here with the 7x. We have to undo positive 2x. Subtract 2x from both sides. 7x minus 2x equals 5x plus 2 equals 5 over there. Since we brought the x's to the left, you got to take that 2, separate it from the x's, take it over to the right. You're going to subtract 2 from those. So we are left with 5x. 5 minus 2 is 3. And again, I'm just giving you some warnings. I have seen students go from here to without showing you a lick of work. You're not going to get full credit. How did you go from 7x plus 2 to 2x plus 5? How did you go from there to 5x equals 3? No work, you're not going to get full credit. You might have the right answer, but you're not going to get full credit. You don't have to do each individual move. You could do this as long as you show me. All right, I want to bring the x's to the left, so I'm going to subtract 2x. And if I'm going to bring the x's over to the left, I'm going to take the constant to the right, so I'll subtract 2. So let's see what we get. 7x minus 2x gives 5x. 2 minus 2 is 0, so the constant's gone. On the right, 2x minus 2x, that's 0. 5 minus 2, we're left with 3. As long as I see that you've undone what's being done. You can make that move in one step, but you have to show it. Okay? Step 3, undo multiplication. 5 times x. Reduce the lowest terms. Well, 3 over 5 doesn't reduce. Okay, number 4. 2x minus 5 equals 2 times x plus 3. Step 1, simplify. On the left, 2x minus 5 is done. On the right, we're going to distribute. So we're going to bring it down. 2x minus 5 equals 2x. And then 2 times 3 is plus 6. Focus on the variables. Are we taking x to the left or to the right? To the left. So if we're going to take x to the left, we're going to subtract 2x from both sides, and then all of a sudden, hold on. What's 2x minus 2x? 0. So all you have left over here is a negative 5. And over here, 2x minus 2, that's gone. So all you have left over is a 6. No more x's. Uh-oh. You're supposed to solve for x. I ain't got no x. Can't solve for something that's not there. Which is why we have step 2.5. No matter what we plug in for x, no matter what we plug in, it's going to cancel out no matter what. Because you're going to go 2 times that number here, 2 times that number there. When you subtract it from both sides, whatever you plug in is gone. So no matter what you plug in, it doesn't matter. What matters is the leftovers. What we have left over is negative 5 equals 6. Is that true? So if that's false, no matter what we plug in, will never work. No solution. So here's the deal. Here's the 2.5 part. If, once you do step two, if the variable cancels out of the equation, you check the leftovers. Or check what's left over. Because all you're going to have left over are numbers, because the variable is canceled out. If the leftovers are false, then x equals, and I want you to write this as is, showing you right here, no solution. Nothing works. There's no answer you can plug in that makes the left or right side. And if the leftovers are true, then what do you think x will be?
So if it was like 6, it would equal 4.
Then it would be,
X would equal 6.
but x is gone. Have no x. All I have left over is a 6 equal to 6, but there's no x to actually that I'm solving for. So here's when x cancels out, then x doesn't matter. It doesn't matter what you plug in. If it's false, nothing could work. Absolutely nothing is going to work because, first of all, it cancels out. So no matter what you plug in, it doesn't matter. You're always going to get something false. If I plug x equal to 2, I'm going to get a false equals, false equivalence. But if what I plug in is always going to be true, then I can plug in anything. And if I can plug in anything, that means the answer would be all real numbers. Every single possible real number would work. And there's an example in here that's all real. So on this one, at the bottom of the box, you would write x equals no solution. Now, I've noticed some of you from the quiz, when you get 0, I've noticed that some of you write your 0 with this. And I know why, because that's how you've been taught to write it so they don't get confused with O's. And actually, in the military, I've been told, I've had students that have been in the military, they're taught to write their zeros with that little slash through it so they don't get those confused with O's. However, in math, that means something completely different. That symbol is empty set. So it doesn't mean 0, it means empty set. So if you can, please go back to writing a 0. I will not expect that you write x equals O, not an answer. Okay. But that's why I want you to write no solution. That way it's taken care of.
It's so ingrained in my head. I accidentally do that.
I'm not going to take it out now, but hopefully the context of the question leads me to the answer. Yeah. So that is a standard for zeros.
Okay.
Yeah. So I'm not like being a jerk because I want you to reduce fractions when the military will make your own laps or something. I think it's one that will back. So
So number 5. 16x. 14. You know, I've always been, I didn't always put little belts through my sevens, but when I started teaching, I realized my sevens look horrible. And if I'm not careful, they're gonna get confused with something else. Same thing with my Z's, because my twos aren't always clear cut. What I was good about twos, I would draw my twos like this. So when I make a Z, I put the little line through it so they don't get confused with twos. Okay. For English major to put their letters in my mouth. Okay. Simplify both sides. On the left, from left to right, can't do anything with 16x plus 4 because you have to multiply before you can do anything anyway. So from left to right, bring it down. You got your 16x and then distribute 4. Positive 4 times positive 3x, positive 12x. Positive 4 times negative 7 is negative 28. Equals, what's 12 minus 2? Not here. Not here. Because, parentheses first, you can't do this. Subtraction, does subtraction happen before or after multiplication? Subtraction before? Let's see, Persephone, Euclid, let's see, Mesai, Democles, Aristotle, and Socrates. Because I'm not going to do, please excuse my dear Aunt Sally. Okay. Does subtraction happen before or after multiplication? After. So you can't do 12 minus 2 until you multiply the 2. Okay. I give this problem on purpose because I will see tens. Don't do that. Don't be that person. So bring down the 12. It's a negative 2. Negative 2 times positive 15 is now negative 30. Negative 2 times negative 4x, that's a positive 8x. Careful with your signs. Just one step at a time. Then keep simplifying. On the left, you still have some stuff you can do. 16x and 12x, that's 28x. And a minus 28. Equal to, on the right, 12 minus 30 is negative 18. And then a positive 8x. Or, remember what I told you about, it's always nice to have the variable and then the constant. So I'm looking for the x's. There's only one term, so positive 8x. And then the constant, a positive 12 take away 30 is a negative 18. So negative 18 plus 8x, 8x minus 18 are the same thing. This maintains that sense of order. Whatever you choose to do, practice it that same way all the time. Step 1, simplify both sides. Step 1's done. Step 2. Are we gonna bring the x's to the left? And if we do, subtract 8x from those two. Or are we gonna take the x's to the right? If we do, subtract 28x from those two. That's right. On to the left. Because if I take away 8x, 28x minus 8x is positive. It doesn't matter, but if we stay positive with the x's, we don't have a negative that we have to subtract. Subtract 8x. 28x minus 8x is 20x. Minus 28 equals negative 18. And again, doing it left to right, bring down what's left over, top to bottom. Since we took the x's to the left, we want to undo negative 28, take it to the right. Add 28. X equals negative 18 plus 28 is, okay? So that's step 2. Separate the variables and the constants. Step 3, undo multiplication or division. 20 times x divided by 20. Simplify. What's 10 over 20? 1/2. I'm 6. Same thing. 2 times x is 2x. 2 times positive 3 is plus 6 equals 2 times x is 2x. 2 times 4 is positive 8, and then we have minus 2. So finish the left and the right side. We have 2x plus 6 over here, 2x. 8 minus 2 is plus 6. So when we go to gather all the variables on one side, if I subtract 2x, the variable cancels out, just like it did in question number 4. If the variable cancels out, check the leftover. 6 equals 6. Is that true or false? It's true. So if the leftovers make a true statement, then x is equal to all real numbers. No, because it's not an interval, because we're not solving a inequality. Because that would mean that there's a range of numbers. We just want what makes this thing work, all real numbers will work. But you'd only plug it in one at a time. Number 7. So the directions on number 7 say round to the nearest 100. So it's decimal time. (0.42x) plus 0.17. 2x plus 3 equals 2.2. 2.5x minus 5. So, but yeah. Whenever you're gonna round something to the nearest hundredth, you're gonna need to know what's going on in the thousands place. So here's the deal, don't round until the very end. Now, you can use a calculator for any of this, but when you think about it, the decimals that I gave you, if you treat it like money, it makes a little more sense. So 0.42x, that's like 42 cents times x. 0.42 times x. We have to do this distribution. So positive times a positive, 17 cents times 2, that's 34 cents. So plus 0.34 times x. And then 17 cents times 3, so that's 51 cents. So plus 0.51 equals. Now that's 2.2 times 2.5. So that is going to be, let me see. So 5.5x, right? And then 2.2 times negative 5 is negative 10.10. There we go. $2 times 5 is $10, and then 20 cents times 5 is another dollar, so that'd be 11. Okay. 42 cents plus 34 cents is going to equal 76 cents. So 0.76x plus 51 cents equals 5.5x minus 11. So now we want to get x on one side. So you have a choice. Think it through. Subtract 5.5x from both sides and bring it to the left, or subtract 0.76x from both sides and take it to the left. So do we want to bring left? Take it left. Right. Take it to the left. So subtract 76 cents from both sides. So that leaves us 51 cents, 0.51, equal to, this is 4.74x minus 11. Is that okay? Mm, 1.7. So we got to bring the 11 over to the left-hand side at 11. Well, that shouldn't be too hard. 51 cents plus 11 is $11.51. Is equal to 4.74. So simplify both sides completely. We distributed We still have right here something we can combine together. So we added this amount, 0.42x, 0.34x, 0.76. So now both sides are simplified. We brought the variable term over to the right side, subtract 0.76x from both sides. Brought the constant over to the left side. We had to undo negative 11. We added 11 to both sides. So now we're at step 3. We have multiplication. So we divide both sides by 4.74. Now I want to point out right here. Some of you are gonna do this and it's wrong. You're trying to solve for x, so that means you need x on your right-hand side that we're solving for. If you divide and you put x there, then you have just made this into a 1. There's no x there anymore. But it's like you're in some other mode, like you're in this robot mode where you just see whatever here, you just divide whatever's there underneath here, and you're not seeing the bigger picture. You're trying to undo what's being done to the x. So we have x. We want to leave x there, so we just divide by that part. The calculator. $11.51 divided by 4.14. And the directions say the nearest 100. So right now I have 2.42827042 equal to x. The 100th. A penny is 1/100th of a dollar. So it's 2 decimal places. That's the 100th place. To know how to round this, you got to look at the 1,000th place. So 8 rounds this 2 up to a 3. It's 2.43. Or turn the projector on. Fading with on canvas. So we're going to do number 8, number 9. So on Tuesday night, I sent this announcement out. Chapter 1, bonus clues. And so inside information, chapter 1 bonus, the clues, section 1.3, 57, 66, 1.3, 83, 86, 1.4, 59, 60, chapter 1 review, number 21, 1.6, okay, it's like 1.7 and 91, and then right there. Solving an equation with fractions in it. Okay. So we're going to do that in addition to number 8 right there. which is gonna fill in the rest of that step. Yes. As soon as I see a fraction problem come across on a test, I see lots of blank test questions. You don't have to do the problem with fractions in it because you have the ability to undo the fractions. One of the first steps for any kind of question when you have to do fractions for solving, undo the fractions. Multiply every term by the least common denominator. So simplify both sides completely. Undo fractions, if we have fractions, undo fractions by multiplying each term by the least common denominator. So strategy, this is not how you do it. I'll see this. Oh, so I'm going to undo the 4. So they multiply that by 4, they multiply by 5, they multiply by 2, they multiply by 3. You just multiply everybody by a different number, it's no longer an equation. Because you got to multiply both sides by the same number. If you multiply all those individual fractions by different numbers, you just changed everything. So that's not the least common denominator. What you need is one number that will undo all of the fractions. The least, and the middle word common denominator. So I need a denominator that will undo a 4, a 5, a 2, and a 3. So over here, I'm going to think about just the denominator. What's the first number that 4 and 5 can be undone with? A 20. If I multiply by 20, then 4 can go into 20 evenly. 5 will go into 20 evenly. If I multiply this by 20, 2 will go into 20 evenly. But here's a problem. 3 does not go into 20 evenly. So the first number that will undo a 4 and 5 is a 20. The 2 is part of that part. The first number that will undo a 20 and a 2 is still a 20. But here comes the 3. What's the first number that 20 and 3 will undo? 60. See, 20 is only going to go into, 20 is only going to be able to go into 40, 60, 80, 100, and so on. Well, 3 does not go into 40 evenly, but 3 can go into 60 evenly. So the first number that all denominators can go into evenly is 60. That's your least common denominator. But I'm not looking at all 4 denominators, 2 at a time. I could have looked at 4, 5, 2, 3, the 2 and the 3 first. First number that these 2 will go into is a 6. Now I have the 5. The first number that 5 and 6 go into evenly would be a 30. And then now 4 wants to join the party, 4 does not go into 30. The next number 30 goes into a 60, 4 will go into 60 even. Could have looked at the 2 and the 5 first, the 5 and the 3 first, 4 and the 2 first.
But you look at two numbers first. Then you find the next two, okay?
So my least common denominator is 60. So we're going to multiply every term. Each individual fraction is going to get multiplied by 60. So right here, 4 goes into 60 15 times. We're left with 15 times 3 times x. That's 45x. Minus 5 goes into 60 12 times. 12 times 2 is 24. Equals 2 goes into 60 30 times. 30 times 9 is 270 times x. Plus 3 goes into 60 20 times. 20 times 4 is 80.
No more fractions. And that was the whole purpose of multiplying by 60. Is to not have fractions. So then finish step 1, simplify both sides completely. Well, that's actually also done. There's nothing else I can or need to do on the left or the right. So any questions so far about what just happened in step 1? Okay. Step 2, pick a side for the x's.
Do we want to bring the 270x over to the left or take the 45 over to the right?
45.
So we're going to subtract 45x. So that leaves, don't forget, this is negative 24. Don't forget the negative. Equal to 270x minus 45x is equal to 225x plus 8.
And since we took the x's to the right, we got to bring the 80 over to the left.
So we subtract 80. Negative 24 minus 8 is negative 104 equal to 225 times x.
So step 2 is done. Separate the x's and the constant. Step 3, we're going to do what?
Right.
Divide by 225. Divide each side by 225. Reduce to lowest terms. So x is equal to a negative number. And this has nothing in common. This won't reduce. Negative 104 over 225.
The only thing that goes into 225 is 15 times 15.
Times 15. And the only thing going into 15 are 3 times 5s. Well, 5 does not go into 104 because it doesn't end in a 5 And 3 doesn't go into 104 because 1 plus 0 plus 4 is 5. So if the sum of the digits is not divisible by 3, then the number is not going to be divisible by 3.
Rules of divisibility. So the final answer is negative 104 over 225.
And then number 9 example is like your bonus question. But I have a lot of denominators. I got 9, I got 15, we have 4, 3, and 10. 9 and 15. What's the first number that 9 and 15 can go into? 35. We're going to 35? Nope. Again, if I multiply by 3, is that going to undo a 9? No. If I'm going to undo a 9, I got to multiply it by at least a 9. So 40. 45. $45. 9 times 5, 3 times 15, 45. So if it was just an 8/9 and a 14 over 15, 45 would undo those enough. But I have a 4. So now 4 wants to join that denominator part. Again, I'm just looking at 2 numbers at a time. So now we'll bring the 4 in. 4 and 45. Well, the next number that 45 can go into would be a 90. 4 doesn't go into 90. Then 135. 4 doesn't go into 135. And then a 180. 4 goes into 180. So the next number that 45 and 4 that they can go into would be 180. That would be the next least common denominator. Because that's 4 times 45. That's the best we can do. And then 3 wants it. What about 3 and 180?
Yeah.
What is it?
60.
60 is not going to undo a 180. 9 does not go into, if I use 60, 9 doesn't go into 60. I can't go smaller. We got to keep going. We either stay the same or we got to go bigger. What's the next number, or do I have it already, that 180 and 3 go into even? 180. It stays 180. 3 will go into 180. And then now 10 wants it. Hey, I want to be part of that. What's the first number that 10 and 180 can go into even? 180. Because it ends in a 0. The least common denominator is 180. The only number that's going to undo all of those fractions is 180. That's okay. If I start somewhere else, let's say we start with 3 times 10, or 3 and 10. The first number that 3 and 10 can divide evenly is a 30. And then here comes the 4. For 4 and 30, that would be 100. No, sorry, that would be 60. That would be 60. And then 15 wants it. 15 and 60. 15 goes into 60 4 times, so it's still 60. But then here comes 9. 9 doesn't go into 60. Well, the next number 60 goes into is 120. 9 does not go into 120. The next number 60 can go into is 180, and 9 will go into 180. So for 9 and 60, it would be a 180. So I can still get that. But I'm taking it 2 numbers at a time. Any 2. And once you find that common denominator, bring down another number. It has to either be bigger or it stays the same. We can't go smaller because it won't undo the denominator. Everybody gets multiplied by 100. This one. This one. This one. This one. This one. And don't forget this one. Everybody. Because if you don't do all the terms, it's no longer. And if you don't like what I'm showing you, then by all means, solve it with the fractions. Trying to make it easier. Watch. 9 goes into 180 20 times. I'm left with 20 times 8, which is 160. Minus 15 goes into 180 36 times. We're left with 36 times 14. 504x. Forget about that extra. And then plus 4 goes into 180 45 times. 45 times is 7. And 315. 8. 3 goes into 180 60 times. 60 times 10 is 600. Plus 10 goes into 180 18 times. 18 times 3 is 54 times x. Minus 4 times 180 is 720. No more practice. Step 1, simplify both sides completely. Undo fractions by multiplying each term by the least common denominator. I've done the fractions. I'm still in step 1 because I haven't simplified yet. Okay. So on the left side, gather all the x terms together. I have a negative 504x. And then my constant, 160 plus 315 is 475. Equals. Over here, 54x. That's my variable term. And then my constant, I have 600 minus 720, so that's negative 120. Yeah.
Divided by 180, I got 12.
Good right here?
Yeah.
Yeah. Okay, thank you. 12. For some reason, my head's off 5. Yeah, my head's off 5. Thank you. Thank you for not waiting. So 12 times 14, so 12, that's 40. What was it, Gabe?
Yeah.
168x, so 1. Wow. So now, do we want to take the x's to the right by adding 168x to both sides, or bring the x to the left by subtracting 54? So we add 168x. So that leaves 475 equal to 54x plus 168x is going to be 2. We're going to have 11, 12. We have 222x minus 120. And then we add 120. And separate the constant over on this side. We get 595 equal to 222 x. Divide by 222. That won't reduce, that's lowest terms. 595 divided by over 222. The only thing going into 222 is 2 times 111. The only thing going into 111 is it can be 3 times 37. But it doesn't reduce. Now, in terms of these examples, we actually did 26. 26 was one of the problems that we did in the warm-up. It was number 2. It was just hidden. Right there. I changed it to 4x minus 3. It was 4x minus 3 plus 3x equals 1 plus 8x. So we did the 26, 32. 32 is a fraction. And I'm just going to walk you through that step because we just did fraction types. You want to undo the fractions. If there's something nice about 32, you might want to notice. Okay, so first question. How many terms? How many terms do we have on the left-hand side?
Great.
2 terms. There's only 2 terms on the left-hand side. Now, you look at there and you see that x minus 2, and you don't count that. This is one term, 3x over 2. And this is multiplication. This is all a single term. If you distribute the 1/4, if you distribute and get 1/4 x minus 1/4 times 2 is going to be minus 1/2. If you distribute, now you have 3 terms. But right now you have 2 terms. You could distribute and then undo the fractions, or if you want, you can undo the fraction of right now. The only denominator is causing trouble is a 2 and a 4. So what's the first thing that 2 and 4 divide into? What's the least common denominator?
4.
4. The least common denominator is a 4. So I'm going to multiply this term by 4 and this term by 4 and hopefully it's the other side. 2 goes into 4 2 times. That's 6x. Plus, now here's what's nice is I reduced the 4s before the actual distribution happened. Now it's just x minus 2 equals 4. So I've reduced that fraction before I even have to distribute the fraction. Okay. You can distribute it and have individual fractions and then simplify, or reduce the fraction before you distribute. But you gotta have a plan in place. You gotta think about it through. And then we've already solved things. That was 32. 34, they do a little switcheroo on 34. And then we're gonna pick up with, if you notice, I have the example 39, and then we go back to 36. I'm gonna save that for Tuesday. But 34. Here's the little switch that they play. We have x minus 11 over x equal to x minus 9 over x, and then a plus 2. This equation has fractions in it. We want to undo fractions so we don't have to deal with it. Well, what's causing the trouble is the denominator. What's in the denominator? X. And it's just x in both denominators, right? So what's the least common denominator for those two fractions? Just x. I want to undo this fraction. So to undo this 11, x minus 11 over x, I would have to multiply times an x. That will undo the fraction. It will undo this one as well, because that's the only thing in the denominator. So the least common denominator here is just an x. I'm going to multiply this times an x. This one's going to get multiplied times an x. And don't forget this one. All the terms get multiplied by an x. Now, it reduces. So all you have left over is that x minus 11 equal to this reduces. So this is just x minus 9 plus 2x. The whole purpose is to undo the denominators, to get rid of the fraction. And then we simplify, because we're not done with the right side. This is x minus 11 equal to. On the right-hand side, what do I end up with? How many x's do I have? 3x. 1x and 2x make 3x and a minus 9. Simplify both sides completely. Now let's get all the x's either on the right or bring it to the left. What do you want to do? So subtract 1x from both sides. You have a negative 11 equal to 3x minus 1x is 2x with a minus 9 still. So now you have to do what? Add 9 to both sides. Negative 11 plus 9 is negative 2. And on the right side, you have a positive 2x. So we undo multiplication, divide by 2. And we get x is equal to negative over positive with the negative. What's 2 divided by 2? X equals negative. We will pick up with 39 on. The notes in the examples are exactly the same. Well, basically, we have all the notes for 2-1 and 2-2. So if you want to get it all done, you can. Why wait? Okay. I'll have your test and everything for you on Tuesday.